Welcome back to the channel. Spent a lot of time on this cylinder head machining it. Had some welding done on it. It's quite broken up, so got it all welded up. You can see there's welds all over it. It's got to machine all those down, and they're pretty rough, so it'd take a lot of machining to do that. Had to take real light cuts. Here's part of my jig I had to make to mount that part on the lathe. I went through the igniter mount hole, and that is off center, and that's a two inch piece of steel there, bar, and that's mounted through the flywheel. So it makes it so the flywheel runs true and I can machine it. And here's my setup. Got my tool stuck way out because of the geometry here. It wasn't ideal, but it's the way I had to do it. Basically, I had to take about a 15 thousandths cut, just because anything heavier than that it would want to break the insert. So it was kind of an interrupted cut even when it was cutting continuous because of the dissimilar metals. So just a really hard part to do. I spent several hours on this, but it did turn out really nice. Just take my time, do it right, and come out with the right result. So let's listen to the interrupted cut here. So lots of hours in front of the lathe. These cylinder heads were not a very good design. The castings weren't very good. Cast iron just wasn't very good then. But certainly this design wasn't very strong. That's a hollow head. It's got a water jacket in it, so it's a wet head. And it was prone to cracking. It was a kerosene engine, throttle governed, so it ran really hot. And they were just known for cracking. There was some cracks on the face of it, and then back on the gasket surface and around the side there was just a lot of cracks. Plus it's a very weak casting towards the back there. You can break the head if you try to pull it off, and there was a lot of carbon buildup in these engines with the kerosene fired. So it's hard to get the cylinder head off, and it has jack bolts, and you start pulling on that, you'll end up breaking the head. So luckily all the pieces were there and was able to get it welded up. Guy that welded it for me did an excellent job, and now I just need to machine it down and make it look nice, and just get it done. So here we are several hours later. You can see that finish I got on that gasket surface there. I'm quite pleased with that. Just a slow, light cut, and it still sounded like it was interrupted when it go across that hard nickel rod. I might have got away at this point running the lathe faster, but I just didn't risk it because I don't want to break any more inserts. And the finish was just turning out so nice that I just left it alone. Here's a shot at the compound feed on the lathe, just how slow it's moving. You can see that handle move, but it's not moving very fast. It's almost comical how slow it is. But just a long time here on this cut, but it sure does make a nice finish. And we'll come around here and look at the process from the other angle. Just about done at this point. Cylinder head's done, and some assembly now. That's right, crankshaft's going to go in the engine. I got the piston and rod in it in the last video, so the crank's going in. Crankshaft weighs 68 pounds on this engine, and it's kind of an obnoxious thing, and trying to feed it through this crankcase without smashing my fingers. There's just not a real good way to get a hold of this thing, so you just got to do what you can. Just work it in there and not try to smash the Babbitt bearings. I didn't have to remake those Babbitt bearings, so I'm thankful for that. I would have, if they were bad enough, but they weren't. They were in good shape, so I'm going to run them. So I certainly don't want to damage them now, but try to get it worked in here. Like I said, this crank weighs 68 pounds, and it comes in through the side of the crankcase. It's the only way to get it in there, and it's a very tight fit to go through there. They didn't make any extra room, but get it dropped in here and then get it lined up. So there it is, it's all in. Now I'll get it bolted up to the rod, and that'll be one more part on the engine. Feels good putting it back together. Starting to look like an engine now. One more part to go on this video is the side shaft. This side shaft, I'm guessing it probably weighs 50, 60 pounds. It's got the governor on it. This side shaft runs the governor, runs the speed setting, runs the cam lobes for the valves, runs the fuel pump, runs the mechanical lubricator for the piston, and runs the lubricator that oils the main bearings. So I'm going to use my engine hoist crane here with a sling on it to hold the nose of that crank up. There's a pin in the back on that crankcase where it locates, so if I can get it hooked on there, it'll hold the back of it. The front be a little obnoxious to try to hold, and I certainly don't want to drop it. So we'll let the engine hoist help out here. So I'll try to get it on that pin and get a couple of bolts in it to get it started. There is some cleanup left on this side shaft, but I'm just going to do that on the engine. It's easier to do it with it mounted there than it is trying to have it roll around on the bench when you're trying to work on it. So get that pin on there so it's hanging on that half-inch pin, and get a bolt in it. And look at that, bolt went right in, so I'm pretty level. I can see that the nose is down just a little bit, but it's close enough here. And then those gears mesh in the back. It's kind of a goofy gear arrangement. It's almost like a right angle worm drive. So I'll get this other bolt in there to hold it, and then have the side shaft mounted on the back side of the engine. It does run the governor. That's what that piece is back towards the crankshaft. There's the governor housing. I got that all back together. That took several hours to do. It was a very, very tedious process. So I got those bolts tightened down a little bit on the back. It'll still move around because I need to have some movement out of it still, but put a level on here. I'm going to try to get it leveled up, and this took a while. I wasn't paying attention. I was letting the hoist down. I actually needed to go up. I hadn't quite figured it out yet. The bubble kept moving the wrong way, and I couldn't figure out why. It was because I was letting the hoist down. You can see that it'll go slack here in a minute. Yeah, well, that's because I'm going the wrong way. Now it stops, so yeah, okay, now I figured it out. Need to raise it actually, so just raise it back up here about about half an inch or so, and it'll be level. Sure does help when you do things the right way. So here's a little shot of that gear area. I got the side shaft timed. I need to make a key for that gear, but I'll do that later. I've just got store-bought bolts holding the main bearing caps on for now because I need to make some more bolts. As I was saying, you can see a little better shot of that governor assembly there. Just checking level here. Going to bump the hoist a little bit more, and then I'll put the nose support on that side shaft. There's a bracket goes on the nose, and it bolts to the cylinder head and has a bearing in it that holds that nose of that side shaft. It also holds the magneto, so it does a couple of things there. So it's also got a half-inch dowel pin in it, and get that lined up, and then the side shaft will basically be on the engine, and I can keep working on it. So here we are on the nose end of the side shaft. There's that bracket, and we'll get that put on there. I'm going to have to actually let the shaft down and take that sling off of there. It's okay, it's supported on the other end. It won't hurt it to hang there for a little bit. It's well supported, so let's get that pulled off of there. And you can see it's still loose. I don't have the bolts tightened at the other end. That way it'll give me a little bit of wiggle room on this end for alignment. So that bracket slides on there, and then there's pins underneath on that cylinder that locate it properly. So get that started and then try to get a bolt in it. Kind of a obnoxious thing to do here, but it's got to be done. So I'll try to get a bolt in there. That bolt really doesn't want to go in there too well. So I'll switch that one for another bolt. Sometimes these holes don't work just because the dies were worn or whatever, but I did clean all that stuff. But sometimes some bolts don't want to go through, and you just got to find one that does. They're worn in the factory taps and dies, and some of them just don't want to go together. So I am going to make new bolts for some of this. These bolts seem to be okay though, so I'll probably use them. So I'll get one started. That'll take the pressure off of it, so I don't have to sit there and hold it anymore. It is pinned, so it is lined up. And then I'll take this tape off the end. I don't know why that tape was on there. Can't remember why I put that on there, but I did. So take that off. Then I can get this bearing on there. It's got a Babbitt insert in it. That's cast in it, poured in it, and then that just is a nice machine fit that's got a key on it to keep it from rotating. And then there's an eccentric that goes way out on the end of the nose, and that holds the linkage for the igniter trip. So this side shaft does a lot of things on this engine. So get the second bolt in there, and then the side shaft will be on the engine. So pretty nice to be putting some things back together, and it's starting to really look like an engine now. So just a few closing shots here. Like and subscribe if you like the channel and what we're doing here. It's pretty nice to be putting things back together. It's starting to really look like an engine now, so I'm getting pretty enthused. So thanks for watching, and I'll see you in the next video.